Okay, good morning everyone. So today we look at the solution from the second IMO. So this was in the year 1960 and this was also held in Romania, just like the first IMO. And in this IMO there are 7 problems instead of 6, which is normally the case. So 3 for the first day and 4 for the second day, and I'm not completely sure about the timings. But let's just go through the problems. So this is problem 1. It says you have to find all the 3-digit numbers n such that n by 11 equals the sum of the squares of the digits of n. So take n as ABC, where ABC are the digits. So n equals 100a plus 10b plus 10c, right? So for example, if n equal to 957, then 957 equals 100 into 9 plus 10 into 5 plus 7. Yeah, the way. So after that, you pull out a factor of 11 here, and you get this expression. So if 11 divides n, then 11 divides this. Okay. So 11 divides this, and if you look at the minimum and maximum values of this, minimum can go -8 and maximum can be 18. Okay, minimum will be when you just try to keep these small, make b large, so that will be 1 minus 9 plus 0. This cannot be 0 because then it will become a 2-digit number. So this will be -8. When you want to find the maximum value, take this to be 0, take these two as 9, so this will be 18. So if 11 divides this, then the only values that this expression can take is 0 and 11. Okay, so a minus b plus c can be either 0 or 11. And now we just look at case by case. So n by 11 is what? So n by 11 will become 9a plus b and a minus b plus c by 11. So if this is 0, then it's 9a plus b. If this is 11, then it's 9a plus b plus 1. And this equals a square plus b square plus c square. And now you just look at it case by case when this equals this and when this equals this. So when this equals this is the case when a minus b plus c equal to 0. Then a you can write as b minus c. Take this expression, a square plus b square plus c square is 9a plus b, and substitute the value of b. And then you will get a quadratic. And in this one you can see that c has to be even. Okay, so you write that because all this is even, this is 0, this is also even, this factor is odd, so c must be even. So write c equal to 2k and some factors will go out and you have this quadratic, and from there you look at the discriminant, it must be greater than or equal to 0. So from there you see that k can only be 0, after that it becomes negative. Okay, so you take k equal to 0, substitute it here, you will get b equal to 5, and from there you will get a equal to 5. So number is 550. And similarly in case 2, you take a square plus b square plus c square equal to 9a plus b plus 1, and this is 11, so a is equal to 11 plus b minus c. Just put it here, again you will get a quadratic, and this time you can see that c must be odd. Okay, because there is odd number here. Only if this is odd, then the whole expression can be even, and only then it can be 0. So c is odd, you put it here and you simplify it. Again you get a quadratic, you look at its discriminant, that must be greater than or equal to 0. So yes, this expression has to be greater than or equal to 0. That will give b equal to 0. That's the only possibility. After that it becomes negative. Okay, so b equal to 0, yes, just substitute it here, you will get, I think, k equal to 3, I guess. Yeah. K equal to 1 and k equal to 5, I guess. And from there you can see that c has either 3 or it's a 2-digit number. So k equal to 1 and c equal to 3, and from there you get a equal to, you just put it here, you will be 8. So 803. So there are only 2 numbers, 550 and 803. Okay. This is problem 2. It says for what values of x does this inequality hold? So first of all, this denominator, it cannot be 0, and this one must be positive. So From there you get x cannot be 0 and this has to be positive, so x has to be greater than or equal to minus 1 by 2. Okay, if this is x is 0, then this is 1, this is 1, this whole thing is 0, so the expression is not defined. So we have these relations must hold, and after that basically just try to rationalize it. Multiply this minus here, so you multiply with a plus on both sides. This, if you simplify it, will be just 4x squared. Okay, so this is what you get. You square it, simplify, and you'll get a root on one side. You again square it, so you get x less than 45 by 8, and the solution is then x going from minus 1 by 2 to 0 and 0 to 45 by 8. So it cannot take the values 45 by 8 or 0, but it can take minus 1 by 2. Okay, this is your solution. This is problem 3, and from now on all the problems are from geometry. Okay, from problem 3 to problem 7. Well, they are all geometry problems. So this one, so it says there is a right triangle ABC. Hypotenuse is of length a and is divided in n equal parts. N is an odd integer. Then it says alpha be an acute angle sorry for this spelling mistake. It's ANGLE. Subtending from A, that segment which contains the midpoints of the hypotenuse. So you take the segment which has the midpoint of the hypotenuse and let that subtend an angle alpha at the point A. So h be the length of segment, length of the altitude from hypotenuse to triangle. Then you have to prove this relation. So first of all, if you have this right angle triangle and you divide it in let's say 5 parts. So if I drop lines parallel to this here, so this will also get divided into 5 equal parts. Okay, so if this length is a, if it's given, then each part is a by 5. You can easily see that if whole length is c, the length of this segment will be c by 5. And similarly, if I draw lines parallel to this side, then this length will also be divided into 5 equal parts, and the length of each part will be b by 5. Okay, so we take note of this, and after that we can solve it quite easily with coordinate geometry. So you set up the coordinates, take this as x-axis, this as y-axis, take this as the origin 0 0, so take this length to be c, so this coordinate will be c0, take this length to be b, so this coordinate c will be 0 b. After that, let's say this is the midpoint and PQ is the segment that contains this midpoint. Okay, so usually PQ will be much smaller, but just for the clarity, I have just drawn it apart. So what is the midpoint of this? So it will be, this is C0, this is 0b, so the coordinate of this point will be c by 2 and b by 2. Okay, and from there can you calculate the coordinate of P and Q? So this length PQ is, this whole side is a, so the length of PQ is a by n. Okay, because since we are dividing it into n segments, and PM equal to NQ, so PM and NQ are equal and they will be equal to a by 2n. So this length is a by 2n, this length is a by 2n. So from there, I just draw the straight lines like before. So this length will be what? This length will be c by 2n, this will be c by 2n, this length will be b by 2n, this length will be b by 2n. Okay, so this is c by 2n, this two are c by 2n. So from there you can calculate the coordinate of P. So it's c by 2 minus this much, so it's minus c by 2n, and y will increase b by 2 plus b by 2n. So coordinate of this will be c by 2 minus c by 2n and b by 2 plus b by 2n. Similarly, the coordinate of this, so the x coordinate will increase by c by 2n and y will decrease by b by 2n. So coordinate of this is that. So after that you find the slope of this line AP. The slope is what? It's this by this. This is 0, so it's this by this. This minus this minus 0 by this minus 0 is just this by this. So you have the slope of AP, call it M1. And similarly, you have the coordinates of this. This is origin, so you know the slope of this. just y by x. So slope of this is also known. And now the angle, you know the formula, right? So if you're taking from here to here, so tan of alpha will be m1 minus m2 over 1 plus m1 m2. Okay. So yeah, so you can also think of it this way. So if this angle is theta, so tan of alpha plus theta would be m1 and tan of theta will be m2. So tan of alpha is what? Is tan of alpha plus theta minus theta. So it's tan of alpha plus theta minus tan theta over 1 plus tan alpha plus theta into tan theta. So you just substitute these values, you will get this. So b square plus c square, so it's b square plus c square, that will become a square. So you have this, and from here if you compare, so you almost have 4n of n square minus 1 and h and a, and you have bc and a square. So if you look at the triangle, the area of this will be what? It will be half into c into b, right? It's half bc, but it also equals half of a into the altitude, half of ah. It's given. So half of ah will be equal to half of bc. So you can write 2 delta is equal to bc, it's b into c, or it's also equal to a into h. So bc equal to ah. So bc by a will become h. So you just substitute there and you get your final results, which is same as this. Okay. So now problem 4, it says construct a triangle ABC, and it's given HA, HB, the altitudes from A and B, and the MA, the median from the vertex A. So yeah, so if you draw a line AM of length MA, and you draw a line AHA of the length HA from A. So first of all, the points B and C, it will lie on this segment HA and M. If you join these two, the point B and C will lie on this. Okay, so we also have this as a right angle. So this HA will basically lie on a semicircle with AM as diameter. Okay, so HA is actually, you can see that it's easy to find. So you just draw a circle with a diameter MA, and you cut off a length HA from that, and so you'll get that. And after that, you can find BC on this line HAM. So you take B and C at equal distance from M in such a way that if you drop a perpendicular from B to AC, it should be of the length HB. So this point B and C is symmetric with respect to this point M. Okay, so and you can also, maybe you can argue that this point, since this is altitude, it will lie on this semicircle with BC as diameter, but it will not lead you too far. But if there's a small observation, if you draw a line parallel to this from this point, okay, you remove this circle and you draw this line parallel to this, so this will also be of 90 degrees because this is 90 degree, and since this is the median, so length of this will be equal to half of the length of this, okay, because this is the midpoint, and this is also 90 degrees. So this point actually also lies on the same circle which has AM as diameter. So this point also lies on this circle. So this circle becomes important. Okay, it has these two very important points, because if you find this point, you just join this and extend it, and you will find C, and you take a cut off equal length on the other side, and you will get your point B. So okay, and this is our construction. Basically, is the first step is you take AM as diameter of length MA and make a circle, and on one side you cut off a length HA. You can actually cut off on both sides, but since it's symmetric, you will end up with congruent triangles. So you just cut it off on one side, find this point HA, so that this length is of of this value HA. Okay, and after that, from this point M, you draw a circle of radius HB by 2. Okay, so it will cut this circle at 2 points, and that will give you 2 triangles actually. So now you join this, and you join this, you join this, and you look at the intersection. So you extend this, call this C1 from this, and this one, this intersection, you call this C2. So you have this, you found this one, and you found this one, and you find the points which is symmetric with respect to this point M. So if this is C1, you find B1 on the other side at same distance, and this is C2, you find the other point B2 on the same distance. So B1 is here, B2 is here, yeah, so B1 is so B1M will be equal to MC1, and B2M will be equal to MC2. And now you have your triangles. So one triangle is just this, you draw this blue line, so this length is HB by 2. So here you can see if you draw a parallel line, it will be, since this is 90 degrees, this will also be 90 degrees, and the length will be double. So altitude of this will be HB. Similarly, you join this B2, C2, and A. You get another triangle. This length is HB by 2. So if you drop a perpendicular from here, that will have length H. Okay, so that was the construction. Now this is problem 5. So it says consider a cube ABCD and A dash B dash C dash D dash with ABCD directly above the face A prime B prime C prime D prime. Okay. So like this, so you have A B C D, you have A prime B prime C prime D prime below that. Then it says find the locus of the midpoints of the segment XY, where X is any point on AC and Y is any point on B prime D prime. So AC is this, B prime D prime is this. So you take any 2 points X and Y, and you find the locus of the midpoint. Okay, so you set up a XYZ coordinate system. You can use center, you can also use side. So maybe you can take X as parallel to AB, Y parallel to AD, Z parallel to AA primed. So what will be the equation of AC? So it will be just X equal to Y, right? And Z, take this, if the length of cube is 2A, then the Z coordinate is A. Okay, so the equation of AC will be X equal to Y and Z equal to A. Similarly, B prime D prime is 90 degrees with respect to this. So the equation of that will be X equal to minus Y and Z equal to minus A. And you can write it in parametric form. You can write X equal to T, Y equal to T, Z equal to A, and T will go from minus A to plus A. And for this B prime D prime, for the point Y, you can write X equal to lambda, Y equal to minus lambda, Z equal to minus A, and lambda goes from minus A to A. So as the point Y will move, the value of lambda will go from minus A to A. As the point X moves, the value of T will go from minus A to A. So what does the midpoint look like? So midpoint is just this plus this divided by 2, this plus this divided by 2, and this plus this divided by 2, that is 0. So Z equal to 0, X equal to T plus lambda by 2, Y equal to T minus lambda by 2. So the midpoint lies in this plane, Z equal to 0. Okay, so we just take out a section from Z equal to 0, and we look at that. So this will be a square of length sides 2A. This will be your X and Y axis. This is the Z equal to 0 plane. So the midpoint has this locus X equal to T plus lambda by 2, Y equal to T minus lambda by 2. So if you look at X plus Y, it will be T, and T will vary from minus A to A. So the line X plus Y will go from minus A to A. So And the line x minus y, if you look at that, so the value of that will be lambda, and lambda will vary from minus a to a. So the locus is basically the region between minus a to a and minus a to a. So if you plot x plus y equal to a, it will be like this. X plus y equal to minus a will be equal to this, will be this line, and x minus y equal to a and x minus y equal to minus a will be these two lines. So it lies between these two, it lies between these two. So the locus is basically this square. Okay, and if you try to visualize it here, so it will be this section and the square which joins the midpoint of the faces. So this will be the locus. Okay. All right. So then there's part B. It says find the locus of point Z, which lie on the segment XY of part A with ZY equal to 2xz. So uh, again, you have this parametric form for x and y, and z now is such that twice of zx will be equal to zy. So what will be the coordinate of this? So this is dividing the line segment xy in the ratio 1:2. Okay, so the coordinates of this will be 2 times the coordinate of x plus 1 times the coordinate of y divided by 3. Okay, that's your section formula basically. So the coordinate of z, if you look at it, the x coordinate will be 2 into t, so 2 into this, plus 1 into this, so 1 into the x coordinate of this, 1 lambda, and divide by 3. Okay, and the y coordinate will be same, 2 into this plus 1 into this, so it's 2t minus lambda by 3. Z coordinate will be this, 2 into a minus 1 into a by 3. So z will be a by 3, x will be 2t plus lambda by 3, y equals 2t minus lambda by 3. So now you look at the section which has a z coordinate a by 3. Okay, so it will be above that plane that we earlier looked, z equals 0. So, and now, okay, this is your xy coordinate, and you again look at x plus y. So x plus y will be 40 by 3, and as t varies from minus a to a, so this will vary from minus 4a by 3 to 4a by 3. Similarly, x minus y, that will be 2 lambda by 3, and as lambda varies, this will take values between 2a by 3 and minus 2a by 3. So this time if you plot these two extremes, 4a by 3 and minus 4a by 3, and this one, okay. Sorry, this is 2, so this should be 4a by 3. I apologize for the mistake. So this line will be 4a by 3, then it will move up by a distance a by 3 and right to the distance a by 3, and yeah, so this is okay. This is okay. This should be 4a by 3. Okay. So this time it's not a triangle, not a square, but it's a rectangle. Okay, so it lies between these two lines and between these two lines, so it's a rectangular shaded area. This. Okay. So this is problem 6. It says consider a cone of revolution with an inscribed sphere tangent to the base of the cone. So this is the cone, okay, and there is a sphere inside. And then it says a cylinder is circumscribed about the sphere so that its bases lie in the base of the cone. So there is also a cylinder about this cone, this sphere. Sorry. It says V1 be the volume of cone, V2 be the volume of cylinder. Then prove that V1 is not equal to V2, and find the smallest k for which V1 equal to k times V2. And in this case, construct the angles obtained by the diameter of the base to the cone of the vertex, cone at the vertex of the cone, from the base of the cone to the vertex of the cone. So basically, you have to construct this angle. So all right, you look at the V1 is the volume of the cone. So you look at the volume of cone first. So if the radius of the sphere is r, so if you try to look at it in 2 dimension, this is the incenter of this triangle. Okay, so the center, if you join it to one of the edges, it will bisect the angle. Okay, it will bisect it here also, it will bisect it on the other side, and this length is r. So so if you look at the area of the cone, so its area of cone is what? So it's 1/3 of pi r square h, but r is the radius of the cone, not the sphere. So it's rc. I just call it rc. Okay, and h is this. This is rc. So if you write tan to theta, it will be h over rc. So you can write h as rc times tan to theta. So this will be 1/3 of pi rc cube tan to theta. Now rc, I can write it in terms of r and theta. So r by rc is tan theta. So I just substitute it here and bring it in terms of r, everything. Okay, and V2 is the volume of the cylinder. Okay, so V2 is what? It's pi r square into h. So it's pi r square into 2r. Okay, it's pi r square into 2r is that's 2 pi r cubed. So now if you look at k will be what? V1 by V2. So yeah, so r cube will go, and you will have everything in terms of tan theta. So tan 2 theta, you convert it to tan theta by 1 minus tan square theta, and simplified, basically you will get a quadratic. So you can look at a discriminant that must be positive, or you can just complete the square. So sum of this and this is 0. So since this is always greater than equal to 0, so this must be less than equal to 0. So that gives k greater than equal to 4 by 3. So that means k cannot be 1. So if k is not 1, v1 is not equal to v2. And what is the smallest value of k? So that's just 4 by 3. So when k is 4 by 3, this is 0, that will give tan square theta is half. Okay, so this is that, and now if you write tan 2 theta, it will be 2 tan theta by 1 minus tan square theta. So you just substitute it half and root 2 here, which is equal to 2 root 2 times rc. And now we construct the angle. So basically, as long as we find rc and then 2rc and h, we will have this angle. Okay, so you construct a square of length rc. So the length of the diagonal will be root 2 rc, and you double this, and you construct a length 2 times of this diagonal. So you get 2 root 2 rc here, and you double this one on the other side. So this becomes the base of the cone here, this one, and now you have your angle. Okay, this angle is here, and this is the height required. Okay, so this was the construction, and this is the last problem. It says there is a isosceles trapezoid with bases A and C and altitude h is given. So something like this. This side is A, this is C. H is given. These two are equal. It says on the axis of the symmetry of this trapezoid. So on this line, find all points P such that both legs of the trapezoid subtend right angle at P. So you find all points such that this angle is 90 degrees. Okay, and if this is 90, of course from this side also it will be 90 degrees because this is symmetric. Okay, and then it says find the distance of P from either base. So first of all, if this is 90, then if this is theta, then this is 90 minus theta. And since this is 90 and this is theta, then this is 90 minus theta. So this angle equals this, and this angle similarly will be equal to that. Okay, so these two triangles are similar. So now I take this as x, so this will be h minus x. This will be, since this is c, so this will be c by 2, and this will be a by 2. And now I write the relation for the similar triangle. So x over c by 2. So x is the one opposite to red. So x over c by 2 will be equal to this a by 2 over this opposite to blue, it's h minus x. So write that and you get a quadratic, so that means obviously there are two values two of p possible. So you look at the discriminant. So if discriminant is greater than 0, there are 2 points. If it's equal to 0, then it's 1 point. If it's less than 0, then there is no point. This was part 3. Okay, and of course you can also find x from this. X is this. In general, it will have two values. And you can also, if you want, you can also have a look at it from this way. Since this is 90 degrees, so this point P is basically the intersection of this straight line and the circle which has this as diameter. Okay, so in general it will intersect at 2 points, and if you look at the case when the circle will just touch this line, then we have just 1 point, and if it's below this, then we don't have any point. Okay, so you will get the same thing basically. So when it touches, so this length here from the section, so this is C, this is A, so the midsection would be what, A plus C by 2, and this will be half of that, so it's A plus C by 4. So this will be equal to the radius. The radius would be what, it's yeah, it's, and so if you drop a perpendicular, this will be h, and this will be c minus a by 2, so it's h square plus c minus a by 2 whole square. That will should be equal to c plus a by 2 whole square, and that should give you basically the same thing. Okay, so yeah, so that was it, and I hope you enjoyed it. So if you have anything to say, please feel free to write in the comments or send me a mail. Otherwise, thanks for watching, and I'll see you next time. Okay, bye.